Let me ask you a question. Is this an equation? Well, maybe it doesn't look too complicated, but in fact it is an equation. Why? Because it actually has an equal sign in there. When you think of equation, you should think equal. So equation equals, right? That's how you can remember that. So in this case, this is simply saying that x, the quantity x, which is some variable, is equal to the number 2. All right? Now let me ask you this. Is this an equation? 7 times x is less than 8. Is this an equation? So let me actually write down here. Yes, this is an equation. Is this an equation right here? And the answer is no. This is not an equation because there is no equal sign here. I have a less than symbol. So it does tell me something. It tells me that 7 times whatever x is has got to be less than the number of 8. It tells me useful information, but it's not an equation because it's not set equal to something. So that's really what you need to be looking for there. What if you had something like x plus 7 is equal to 0? Is this an equation? And the answer is yes. It is an equation. Why? Because you have an equal sign. And what this is telling me that whatever x is, I need to be able to add 7 to it, and then whatever I get has got to be equal to 0. What about something silly like 1 plus 1 is equal to 3? Is this an equation? Well, you might not believe me, but it actually is an equation. Now, I grant you, it's not true. This is not a true statement. 1 plus 1 is 2. It's not 3. But it is an equation because it has an equal sign. So what you're doing in algebra is you're trying to look for places when you have an equal sign, something equal to something else, and that's an equation. Now, whether or not this is true, whether or not it's valid, that's different. And obviously 1 plus 1 is not equal to 3. So you can't say that that's true or valid or even represents reality, but it is an equation. So it's very simple, really, when you're looking to identify if something is an equation or not. And I want to take just a minute to kind of talk a little bit about the big picture here. Why do we care about equations? I mean, ultimately, everything around you is governed by math, believe it or not. Even, things that you do when you go to the playground when you were like a kid. For instance, if you were going to the playground, right, and you decide to take this baseball here, right, and you decide to throw it. You don't throw it horizontal, you don't throw it vertical, you throw it at some angle like this. What's this ball going to do? This ball is going to go fly up, reach some maximum, and it's going to go down, and of course, hit the ground. But it's going to follow some path. And if you throw this baseball at the same angle, at the same speed, 1 time, 2 times, 3 times, 4, 5 times, it doesn't matter. If you throw it at the same angle to the ground, at the same speed every time, and if the wind is the same, and if the ball is the same, and if you do everything the same, then that ball should fly exactly the same every single time. That's nature, that's physics. And of course, physics, it follows the rules of math, right? So this ball here, believe it or not, can be expressed as an equation. You can describe the path by an equation, in other words. In other words, I might have an equation that might describe, how high it goes as time goes on. And I might have an equation that describes how far it goes. Because obviously, the distance it travels is going to depend on how hard you throw it and the angle, right? The angle to the ground that you throw the ball. So all of these things can be wrapped up in these equations. So I might have an equation, for instance, that predicts how far this ball is going to travel. And I might, as inputs to that equation, I might have the angle, I might have how hard I throw it, I might have the wind speed, maybe that's another part of the equation, because if the wind is blowing against this ball, it's going to change everything. Maybe gravity's in there, obviously, gravity's got to be in there. Maybe we're throwing this ball on the moon, right? If we're throwing the ball on the moon, the gravity's different, there's no wind resistance, the equation changes a little bit. But in any case, if I'm interested in figuring out how far it travels, or if I'm interested in the path and the shape of this guy, it's all governed by equations. So I may have an unknown that I care about. Maybe the unknown is the distance that ball travels, right, or something like that. And then I'll have this equation, and I might need to solve that equation for that distance. So I might have all these numbers and variables, and then I need to actually solve the equation for d, the distance that this ball actually travels. As another example, a little simple example, you've heard of the Leaning Tower of Pisa, right? So I'm not a great artist, but here's the Leaning Tower of Pisa. So I might climb to the top, and I might decide to drop a ball from the top, right? So I might start here, and basically what's going to happen is this ball you know, is going to fall down. Now, we all know that when we drop the ball, it's going to start slow, right, from 0 speed, and then it's going to accelerate and go faster, 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 faster until it hits the ground, right? But maybe I'm interested in how fast is this ball traveling when it hits the ground. How many meters per second, or how many, whatever speed you want to use, whatever measurement you want to use, how fast is that ball going when it hits the ground? What is going to be dependent on that? Well, obviously, the height of the Leaning Tower of Pisa is going to be a big part of it, right? What else do you think could possibly influence that? Well, the force of gravity. I mean, if I do this on Jupiter, or if I do this on Mars, it's obviously going to be a different speed whenever I hit the ground. Maybe, again, there could be wind resistance or air resistance, or any number of things. The mass of the ball, I mean, who knows what it might be. You have many, many factors that you might need to go investigate to go figure out how fast this guy is going when it hits the ground. And so you'll have an equation that represents all of those factors, and maybe I need to solve that equation for the speed that this ball has when it hits the ground, okay? And so I have an equation sitting in front of me, and then I have all the numbers put in everywhere, and then maybe I need to solve for the speed. I might call it v for the velocity or something like that. And I might simplify and solve this equation and find that speed. So I guess what I'm trying to show you is two different examples of real life. In real life, you might need to know and calculate something. And you don't know what the answer is ahead of time, but you know all the factors that go into the answer, and you have an equation that describes how it behaves, right? And then you solve that equation for the unknown quantity. That's kind of motivation, because ultimately in this section, all we're going to be doing is solving equations. We're going to start with simple equations, equations that are so simple that you don't even need to solve them. You can just tell me the answer. And we're going to incrementally make them more complicated, and you'll see that once you understand the pattern, none of it's hard. All right? So, but we have to crawl before we can walk. So what I'm going to do here is erase the board and start putting some simpler guys up here for us to solve. So before we actually solve an equation, let me write one on the board. X plus 2 is equal to 3. The unknown quantity is x. Now, we know this is an equation because it has an equal sign. And let me go ahead and put a semicolon here, and I'm going to tell you that x is equal to 1. And I'm going to ask you, is this a valid solution for this equation? Now, the way you figure that out is you actually take x and you plug it in there and see if it satisfies, if it's true. So let's put 1 in here, and what we'll have is 1 plus 2 equals, with a question mark, because I'm not sure yet, 3. And I think you can realize and understand that 3 is equal to 3, so yes, this is a solution. So what you figured out is that x is equal to 1 is the solution. It's the only number that works for this equation. And we've proven that it works because we take the answer, we stick back in there, and we verify that it's true. All right, so let's do another one of these guys. Let's say we have a minus 7 is equal to 0, and let's say that a is equal to negative 7. And we're trying to figure out, is this a valid solution, or is this the solution to this equation? So let's put it in there. Negative 7 for a, minus 7, question mark, is that equal to 0? Well, if we go back to adding and subtracting numbers, we're already starting with a negative 7, and we're subtracting 7 more. So based on what we've done in previous lessons, you should realize that this is negative 14. And this is definitely not equal to 0, so no, this is not the solution to the equation. And by the way, I'll take a second to tell you that when we actually start solving these equations and you get an answer, the great thing about algebra is you always know if you're correct. Because you can take that answer and you can stick it back into the problem like we're doing here and see if it works. And if it does work, then you've done everything correctly. And if it doesn't work, then you got the wrong answer somehow. Okay? Let's go ahead and do one like this. Let's do 2 times x is equal to 4, and let's say that x is equal to 2. Now we're trying to figure out, is this the valid solution? So stick it in here. 2 times 2, because we're substituting for x, equals, with a question mark, 4. And I think you would agree that 4 is equal to 4. So yes, this is the solution to this equation. All right, let's do another one. 3 times x minus 1 is equal to 7, and let's say that x is equal to 2. Is this a valid solution to this equation? So we stick x in here, and we'll get 3 times x is equal to 2 minus 1 equals, with a question mark, 7. 3 times 2, we have to do this first because this is multiplication. We get 6. We still have to subtract a 1 like this. 6 minus 1 is 5, which, as you know, is not equal to 7. So no, this is not the solution to this equation because 5, when you plug it in, you don't get the answer you expect. All right, so let's go through. Let's do one that's a little bit different. We'll have y divided by 7 equals 4. And we'll say that y is equal to 28. Is this a solution, or is this the solution to the equation? So let's take value of y and stick it in here. 28 divided by 7 equal with a question mark 4. 28 divided by 7 is 4. So in fact, it does satisfy the equation. Yes, this is the solution. Y is equal to 28. All right. Let's go on and do the next one. What if you have x over 5 is equal to x? And let's ask ourselves, is x equals 0 the solution to this guy? Now this looks a little different at first because we have x in both places. But don't be startled by that. All it means is everywhere you see x, you have to substitute for what you think x is. In this case, it's equal to 0, or so we think. So let's stick it in there. 0 divided by 5 is equal to 0. And we have to figure out, are these things really equal? Well, what is 0 divided by 5? 0 divided by anything is actually 0. So this does satisfy it. Yes, this is the solution to that equation. All right, we'll do one more of this type. Let's say we have 3 times k plus 5 is equal to 5 times k minus 1. And we're going to ask ourselves, is k is equal to 3? Is this a solution to the equation? Notice again, we have k in 2 places. That's okay. You can see the variable on both sides of the equal sign in multiple places, whatever. K is the unknown. I don't know what k is. Of course, in this particular problem, I'm asking, is k equal 3 the solution? So what I do is I just substitute it in. And notice in some of these problems I've been using a, and some of these problems I've been using x, and some of them I've been using other letters. The variables don't matter. In this case, we're using k to kind of show you that. It doesn't matter what variable you use. So let's stick k is equal to 3 in here. So we'll have 3 times 3 plus 5 is equal to 5 times k, which is 3. And that's equal to, I should say, there's a minus sign here, minus 1. And we're asking ourselves, are these equal? So we have to do the multiplication first. 3 times 3 is 9. We still have to add the 5. We'll do that later. 5 times 3 is 15. So we leave that like this. 9 plus 5 is 14. And 15 minus 1 is 14. So yes, this is correct. K is equal to 3 is the solution to this equation. So it satisfies it. All right, so far what we've done is we have not really solved anything. I've given equations and we have taken the answer that's given for the variable, put it in there and verified if it's correct. Right? Now we're actually going to give an equation, and I'm not going to give you any answers. We're going to actually use the rules of algebra to solve the equation for the unknown ourselves. So we're kind of getting into a new type of problem here. We're going to solve these guys ourselves. So let's start with one that's really easy. X minus 7 is equal to 3. Remember, x is a variable. It could be anything. You know, in the other examples we were talking about, x could represent the speed of that ball. Or x could represent the distance that ball traveled, and this equation might represent how that ball travels down the pathway. But we're trying to figure out what x is. Now, this is an equation, so you know that whatever x is, when I subtract 7 from it, I have to get 3. So this particular one is so easy that you can just look at it and figure out what number do you have to put here. You know, what do you have to put here so that you can subtract 7 from it and get 3? Well, 10 is the only number that works. You have to be able to put 10 in here. 10 minus 7 is 3. And there's no other number that's going to work. If you put 11 in here, it's not going to work. If you put 6 in here, it's not going to work. The only one that works is 10. That's the only solution to this equation. But you have to get out of the habit. A lot of students, when they start solving equations in algebra and kind of get these easy ones, you know, they kind of just write down x is equal to 10, no problem. But the problem is, very soon we're going to get to equations that you cannot solve by looking at them. So please do yourself a favor and get in the habit of writing everything down on paper now instead of just throwing an answer out there. Because if you just throw an answer out, I don't know if you know what you're doing or not, or if you just guessed. So here's the deal with an equation. what you need to do, the goal of solving any equation, is to get x by itself. If I can get x by himself, then and I have an equal sign next to him, then I will know what he's equal to, because he'll be equal to whatever's on the other side of the equal sign. So it's like a puzzle. X is over here, he's got some junk with him, and you need to get rid of this junk and move it over to the other side and get x by itself. So we talked about this briefly in the last section. You have a -7 here. How can you get rid of subtraction? You have to do the opposite. You're going to do addition. And the way you're going to do it is like this. You have x minus 7 on the left. I'm going to add 7 on the left, like this. And then on the right-hand side, the other rule you have to remember is whatever you do to the left, you also have to do to the right. You know? So on the left-hand side, I have added 7. And because I did it to the left, I also had to do it to the right-hand side. Now on the left-hand side, I have -7 plus 7. This is going to go to 0. It's going to basically disappear completely. And so because it did that, on the left-hand side of the equal sign, all I have left is x. And on the right-hand side of the equal sign, all I have left is 10. So I get my answer of 10, which is exactly what we know the answer has to be. In fact, you can take the 10, you can stick it back in here. 10 minus 7 is 3. So this is obviously a really simple problem that you don't really have to use algebra to solve. But like I'm saying, very soon we're going to get to some problems that you will definitely not be able to solve by looking at them. So get in the habit of writing this down. You add 7 to the left, you add 7 to the right. You know, I want to kind of illustrate something to you. Equations are kind of like a seesaw. Right, here's the seesaw. This seesaw is balanced. You know, perfectly in the middle, perfect piece of wood, perfectly balanced. If I do something to the left-hand side of the equation, and I don't do anything else, the seesaw is going to pivot and it's going to be unbalanced, right? If I do something to the left, I have to do the same thing to the right in order to keep the equation basically the same, in order to keep it equivalent to one another. You know, we even talked about this a long time ago in fractions. I told you, you can do whatever you want to the top and the bottom of the fraction as far as multiplication and division, you know, as long as you do it to the top and the bottom at the same time. And I told you that's the way to keep it equivalent, right? So if you have 1/2, I can multiply the top by 2, and I can multiply the bottom by 2. And I'm going to represent the same number, but it might look different. It's the same thing here. With equations, I can do whatever I want to the left and the right-hand side, but if I add 7 over here, I have to add 7 over here. If I subtract 3 on the left-hand side, I have to subtract 3 on the right. If I multiply by 4 on the left, I have to multiply by 4 on the right. If I don't do that, then it becomes unbalanced and it's not correct anymore. So what I recognized here is that I have a -7. I want to get rid of it. So I have to do the opposite. I add 7 to the left, and because I have to keep it balanced, I then also have to add 7 to the right-hand side. So let me go and erase this, and what we're going to do is do a ton of additional problems to give you practice with this concept. I promise you that by the time we get done with these problems, it'll be so ingrained because you've seen it so many times, it'll be like second nature. All right, so let's say we have y plus 7 is equal to 12. Okay, so how do we solve this guy? The goal is we want to get y by himself. We have this 7 next to him, plus 7, and that is a problem. So we want to get rid of this guy. The way we do it is by doing the opposite. We're going to subtract 7 from the left, and because we do it to the left, we must also do it to the right. If we didn't do it to the right and we only did it to the left, then we've screwed up and we haven't done anything valid. But as long as we subtract 7 here, we can subtract 7 over here. And by the way, why are we subtracting 7? Because 7 minus 7 is 0. So we basically are trying to get y all by himself. So on the left, all we have is y, and on the right, we have 12 minus 7, which is 5. And that is the final answer. So y is equal to 5. Now, if you're curious if this is correct, you can always check it in algebra. You can take the 5, stick it in here, because y is equal to 5. 5 plus 7 is equal to 12, so it checks out. Everything's correct. All right, what if we have something a little bigger? -37 plus z is equal to 37. How do we solve for z? We're trying to find out what this is equal to. Now we have this 37, this -37 sitting over here. We don't like that. The only way we can really get rid of it is to do the opposite. This is negative, so we have to do the opposite of subtraction, we have to do addition. So negative 37, we add 37 to the left, and if we add it to the left, we have to add it to the right as well. In other words, all we did was add 37 here to the left-hand side, and then of course we had to do the same thing to the right-hand side. The reason we're adding it is because negative 37 plus 37 is 0. And that basically eliminates everything on the left-hand side. The only thing we have left is z. On the right-hand side, we have 37 plus 37, which is 74. The answer is 74. And again, you can check it by putting 74 in for z. Negative 37 plus positive 74 is going to give you positive 37 for a final answer. And I encourage you to check that just to make sure. In fact, honestly, that is really one of the coolest things about algebra, is that once you get an answer, you can always check it. And you always know if you're right. So if you get wrong answers in algebra, there's no reason, because you can always check your answers to make sure you're getting it right. All right, so let's crank up the complexity just a little bit. What if we have 4/3 is equal to negative 2/3 plus x? Notice there's a couple differences here. The first one is I have fractions in here, which scares off a lot of people. The second one is x is on the right-hand side. It doesn't matter where x is. All you're trying to do is get x on one side of the equal sign. Doesn't matter where it is. You just want to get it by itself. So you want to do this using the rules that we're learning here. So since this negative 2/3 is negative here, we want to do the opposite. We want to add 2/3 to both sides. Because if we add 2/3 over here, it's going to go away with negative 2/3. It gives us 0. It's going to disappear. And whatever we do on one side, we have to do on the other. And by the way, let me say, this is a great example of why some students have problems in algebra. Because they come into algebra, they kind of understand the basic idea, and then they get to a problem like this and they freeze up because they don't understand fractions. Math is so important that you build your skills one skill at a time. If you come in here and you don't understand any fractions, you don't know how to add two fractions, then you can't do this equation. And then if you can't do this equation, there's going to be other things later that you won't be able to do because you can't do this. And then you kind of just, it all falls apart. So it's why I take time to review fractions, and I take time to review adding and subtracting negative numbers, and I take time to review a bunch of stuff, because if you don't get it, you just cannot progress. So if this looks scary to you, if these fractions scare you a little bit, then stop, go back to the section on fractions and work those problems with fractions until you're absolutely comfortable with how to add and subtract fractions and multiply and divide fractions. Because it's not going to get, that's not going to go away in algebra. You're always going to have to deal with that. So even though this problem looks more complicated, it's not. You're applying the same thing. What you want to do is you want to add 2/3 to both sides. So you have 4/3 on the left. You need to add 2/3. On the right, you have negative 2/3, and we're adding 2/3 to that. Of course, we have our plus x. The only difference between this and this is I've added 2/3 to both sides. And the reason I've added 2/3 to both sides is because negative 2/3 plus positive 2/3 is 0. I'm trying to get x by itself. Okay, I'm trying to get x by itself. So what I have here on the left-hand side, I've got two fractions that I need to add together. Fortunately, the common denominator is already here. I've already got a 3. So I keep the common denominator, I add the numerators. I get 6/3 on the left, and that's all from fraction arithmetic. On the right-hand side, this goes away, and I have x. Now let me ask you this, 6/3 is really 6 divided by 3, so what is that? So that's 2. So 2 is equal to x. So it doesn't matter that it's 2 is equal to x. It's exactly the same thing as x is equal to 2. You've learned that it doesn't matter if x is on the left or the right-hand side. You still just try to get it by itself, and then you have the answer. So x is equal to 2. That is the answer to this problem. So what if we have negative 3/5 is equal to x minus 2/5? So again, we're trying to get x by itself. On the right-hand side, we have negative or minus 2/5. We have to add 2/5 to both sides to clean this out over here. So on the left, we'll have negative 3/5. We're adding 2/5 to the left, and we're adding 2/5 to the right. We're doing the opposite of subtraction. We're doing addition to get rid of it. And the reason we're doing that is because this is going to disappear. It's going to go to 0. On the left-hand side, we're adding these guys. The denominator's already 5. It's already the same, so we'll just put a 5 there. We have to add the numerators. We have negative 3 plus 2. And we've done a lot of work with adding negative numbers and positive numbers. So negative 3 plus 2, you should convince yourself is negative 1. Because basically the signs are different, so you subtract them, you get 1, and the sign goes with the larger guy. So go back if that's not comfortable to you. You get negative 1 here. On the right-hand side, you get x, which is exactly the same thing as saying x is equal to negative 1/5. X is equal to negative 1/5, and that's the answer. Okay? Now, what do we have next? We're just going to keep working through these guys until it's absolutely comfortable for you. X minus 3 is equal to 12. So there's an equation. How do we solve it? We're trying to get x by himself, so we want to get rid of this negative 3. The only way we can get rid of this negative 3 is by adding 3 to both sides. So we add it to the left, we have to add it to the right. Here, this is going to disappear, so on the left, all you have is x is equal to 12 plus 3 is 15. And that is the final answer for that problem. All right, for our next problem, we have 0 is equal to 5 plus x. So it looks really simple. X is on the right-hand side. How do we solve it? We want to get rid of this 5. This is a positive 5, so we have to subtract 5. So on the left, we're going to subtract 5. And on the right, we're going to subtract 5. So we subtract 5 from the right, we subtract 5 from the left. And on the left-hand side, what is 0 minus 5? Well, that's just negative 5. On the right, this of course goes away. We just have x. So all you have is x is equal to negative 5. And if you're unsure, just take it and stick it back in here. Negative 5. So 5 plus negative 5, you get 0. It all checks out. And that is the answer to that problem. So really what you need to do is take your time with these guys and think through it. What do I need to do? It's like a puzzle. What do I need to do to get x by himself? That is your goal. So, for instance, if you have negative 9 plus y is equal to negative 9, how do you get y by himself? Well, here I have a negative 9. So since it's negative, I need to do the opposite. I'm going to add 9 to both sides. So I have negative 9 plus 9 on the left, negative 9 plus 9 on the right. I add 9 to the right, add 9 to the left. That's the only way that it's valid. On the left, of course, this goes to 0, so I just have y. What is negative 9 plus 9? Well, that's just 0. So y is equal to 0. All right, now we're going to do one that's slightly different. Up till now, we've been doing addition and subtraction. Here, let's do some multiplication. 3 times x is equal to 3. But the same principle applies. There's no addition going on here. There's just multiplication. What is the opposite of multiplication? Or what is the inverse, like we talked about in the last section? The opposite of multiplication is division. So we're going to use division to get that 3, to basically disappear this 3 so we can get x by himself. So let's figure out how we're going to do that. Let me rewrite the problem. 3x is equal to 3. What I'm going to do is on the left, I'm going to divide by 3, and on the right, I'm also going to divide by 3. Notice I can do whatever I want to the left as long as I also do it to the right. I've divided by 3 both places. Now, why would I do that? Because on the left-hand side, I have 3x over 3. The 3 divided by the 3 here is basically going to give you 1. So you can kind of draw a little line through that. We call this canceling in algebra. Canceling is not magical. It doesn't mean it just poof, disappears into thin air. It means it divided out. So what is 3 divided by 3? It's 1. If you divide by the same number on the bottom that you have on the top, then they both just disappear because they goes to 1. So what you've really done is eliminated the numbers because you kind of changed them to 1. So on the left, all you have is x. And on the right, 3 divided by 3 is 1. And this is the answer to the equation. And if you're unsure, just take it and stick it in here. 3 times 1 is equal to 3. So this is the solution to the equation. Okay, so what if you have x divided by 5 is equal to 5, and you want to solve for x? Well, again, you're trying to solve for x, but you have division going on here. So you want to get x by itself, you have to use the opposite of division. You want to use multiplication to do that. So let's rewrite the problem. X over 5 equal to 5. If I take this on the left and I multiply by 5, then I'll also have to multiply by 5 on the right. And don't forget that when you multiply by 5, it's basically like multiplying by 5 over 1, because that's what 5 is in terms of a fraction. And then you have 5 again divided by 5. It's going to cancel out. They're going to basically go away. So on the left-hand side, all you have is x, and on the right-hand side, you have 25. So this is the answer. And if you're unsure, just stick it back here. 25 divided by 5 does give you 5, so that's right. Make sure you understand this. You're dividing by 5 here. The way you get rid of it is to multiply by 5. Because when you have 5 on the top and also 5 on the bottom, they cancel out. The reason they cancel is not mystical. It's because 5 divided by 5 is 1. That's why they go away. In general, in algebra, when you see the same thing on the top that you also see on the bottom of a fraction, I know these are multiplied together, but ultimately they're kind of stuck together as a kind of a large fraction. You just have a multiplication symbol there. If you see something on the top, you can cancel it with what you see on the bottom, and it disappears. And that's how we're getting x by itself. So what we're going to do is just kind of erase this and continue working a little bit more complicated examples. All right, let's pick some larger numbers. What if I have negative 32 times z is equal to 64? How do I solve this? Well, it's the same principle. There's nothing new. I have multiplication going on here. I want to get rid of this negative 32. So let me rewrite it. Negative 32z is equal to 64. How can I get rid of it? Since this is multiplied, I need to divide by negative 32. And if I do it to the left, I need to do it to the right. Divide the right by negative 32 also. It's the only way that it's valid. So here, negative 32 cancels with negative 32. They totally go away. The reason they go away is because they divide out and they give you 1. On the left, you just have z. And on the right, 64 divided by negative 32 is negative 2. You do the division, you get the number, and then from our previous lessons, we know positive divided by negative is always going to give us a negative. So it's the same principle either way. And notice that all of these problems we're doing now are just single-step equations. Later on, we'll get to multi-step equations, but you'll find out that it's all the same thing there as well. All right, what if we have 18 times z is equal to negative 9? How do we solve this guy? Again, we want to get z by himself, so we just take the 18z like this, and we divide both sides by 18. And that's going to get rid of the 18s. So we have z on the left. What is negative 9 over 18? Let's go ahead and write it down. Negative 9 over 18. This is correct. This is the answer, but it's a fraction, and we can simplify this fraction. We can divide the top by 9, and we can divide the bottom by 9. So z is going to be equal to, negative still stays there. 9 divided by 9 is 1. 18 divided by 9 is 2. So the answer we got is negative 1/2. This is just fraction simplification. We've talked about that before. Go back and review it if you need practice. The negative hangs along for the ride. We're just simplifying our fraction to lowest terms. What if you have z over 7 is equal to 14? Well, I have division going on the left, so I want to get rid of it by multiplying. So I have z over 7 here, and I'm going to multiply by 7 on both sides. I can do anything I want to both sides. And what's going to happen here is I have a 7 on top. It's going to cancel with the 7 on the bottom. So on the left, all I have is z. 14 times 7 is all I have on the right-hand side. That's 98. So the answer is 98. And if you're unsure, you take the 98, stick it in here. 98 divided by 7, you're going to get 14 as your final answer. All right, now let's do this guy. What if we have w divided by 7 is equal to 5/7, or 5 divided by 7? We want to get w by himself. It's the same thing. Let's rewrite the problem. We're going to have w over 7 is equal to 5/7. How do we get rid of the 7? It's on the bottom. It's divided, so we have to multiply on the left and on the right. And when we do that, we're going to cancel top and bottom, and they disappear. So on the left, all you're going to have is w. On the right, all you're going to have is 5. And this is the answer. Notice I could cancel this on the right-hand side because I saw a 7 on the top and I also saw it on the bottom. That's the way I wish I can do it. If you didn't realize this, if you didn't realize you could cancel it, you could just do it by regular multiplication. I mean, here, really, this is 7 over 1, right? How do you multiply fractions? Remember, you multiply fractions by multiplying the top and then multiplying the bottom. So on the top, we'd have 7 times 5. Let me just show you real quick. If we didn't do this, we would have 7 times 5 is 35 on the top. 7 times 1 is 7 on the bottom. That would be our answer. And then we would look at this and say, well, 35 divided by 7 is 5. So that's the same thing we get. So no matter if you do the multiplication and then you simplify, or if you simplify ahead of time, you're going to get the same answer either way. And you should always check your work by taking the 5 for W and sticking it in here. If you put a 5 here, what we're saying is 5/7 is equal to 5/7. So of course that's correct. All right, now we're winding through the last few problems we have for this section. So s over -3 is equal to -5/6. Again, I talked about fractions. This kind of problem, scares a lot of students because they don't know what to do first, and they have a fraction there, and that worries them. You treat it like we've always been treating them. We're trying to get s by itself. So let me rewrite the problem. How can we get rid of this -3? It's divided over here. We need to multiply by -3 to both sides of this equation. That's the only way we're going to get rid of it. When you do that, the -3 divides out or cancels with the other -3. Okay? And on the left-hand side, all you have is s. Right? All you have is s. Now on the right-hand side, what do you have? We have -5/6 multiplied by 3. But if that worries you and if you don't understand how to do that quite right, just remember that any whole number like -3 is like -3/1. Now we have two fractions. I can kind of do this to help you a little bit if you like. We have two fractions that we need to multiply. We have negative times negative, so that's going to give us a positive number. Now we just have to deal with the fractions. We multiply the top and we multiply the bottom. That's how we multiply fractions. 5 times 3 is 15. 6 times 1 is 6. So the answer we get is positive 15/6. However, this is not total. So this is the answer, but it's not totally simplified because we can divide the top by 3 and we can divide the bottom by 3. And when we do that, 15 divided by 3 is 5. 6 divided by 3 is 2. So the answer is 5/2. And that's the simplified answer. I mean, truthfully, the answer is 15/6 as well. But to simplify it is what you always want to try to do, so you get 5/6. Now, if you stick this in here, what you're going to get is, once you manipulate it all, you're going to find out that the left-hand side is equal to the right-hand side. We'll switch back to slightly simpler one. 7 times y, or -7 times y, is 7. How do we get y by himself? Well, let me rewrite the problem. -7y is 7. In order to get y by itself, since they're multiplied, we have to divide by -7. It's the only way to do it. And so they're going to cancel. So on the left-hand side, you're going to have y is equal to, and over here, you're going to have -1. 7 divided by 7 is 1. Positive divided by negative is negative. And our final problem of this lesson is b over 3 is equal to 5. And we want to get b by himself, so how are we going to do that? Well, let me rewrite this guy, and we'll say b over 3 is equal to 5. So what we're going to do is multiply by 3 on the left and on the right. And the reason we're going to do that is because this 3 is going to cancel with this one, because we have one on the top and the bottom. So we have b by himself. On the right-hand side, 5 times 3 is 15. And to check your work, take b, put it in there. We said b was 15. 15 divided by 3 is 5. So it is definitely correct. So we have covered really a tremendous amount of material here in this lesson in algebra. Equations really are the fundamental bread and butter of the whole reason why we're using algebra at all. You don't see it a lot of times with these simpler equations because we don't have any application yet. But once you get these basic foundations down, you'll be able to go and look at, how far that ball is going to go, or how fast that train is going to go down the track, and be able to calculate it with the rules of physics, which are basically math equations that you're going to be able to use and solve for whatever it is you're trying to solve for. Maybe I'm trying to swing somebody on a swing, and I want to know how far is he going to go on the upswing. Well, that's governed by an equation. I can solve for that value and find that unknown. Now notice in all of these equations we've introduced something incredibly important, and that is that all you're trying to do is get that variable, that letter, by himself. Once you do that, then you've solved what he's equal to, and that's all you're trying to do. And you can use any tool that you can, and it's legal in your disposal to do that. If you see that there's some addition over there, then you need to get rid of it by subtraction. If you see that there's some multiplication over there, you got to get rid of it with division, and vice versa. So you're trying to do the opposite, basically, to kind of isolate that variable and get him by himself. And when you do that, you've completed everything and you've solved the equation. Also notice in all of these equations have basically been one step. B divided by 3 is 5. All we had to do is multiply. All we had to do here was divide. All we had to do before was add or subtract. We only had one step. In the next section, we're going to get to more complicated equations that are going to require more than one step to solve. They're not going to be hard, but we're building our skills. So do not go to the next section until you are absolutely confident that you understand everything here and that you can work them yourself. So watch this lesson again, pause the video, as I've done lots of problems here. It doesn't matter if you've seen them. Make sure you can solve them yourself. Go get the companion worksheets that can come with this course and solve those extra problems. Grab your textbook, solve some more problems. And then when you're confident that you understand how to do all this and you're absolutely good, solid in your skills with fractions and negative numbers and solving these simple equations, follow me to the next section where we'll solve some more complicated types of equations, and you'll see that they're actually not hard to solve at all. Learn anything at mathandscience.com.